Hello, this is Mr. G, and this is our first video on simple trinomial factoring. Trinomial factoring will usually look something like this. We start with the trinomial, and then we rewrite it as the product of two binomials. Since we're just starting this topic, we're only going to focus on quadratic trinomials for now. That means trinomials that have a highest power of 2. Keep in mind that not every trinomial is going to be factorable, and you'll see plenty of trinomials that are unfactorable as you progress in your mathematical career, but right now we're just going to focus on the trinomials that are factorable. But before you can even try and use simple trinomial factoring, you have to make sure you see a lead coefficient of 1, an invisible 1 in front of the first term. If this first term has any other coefficient, things are going to get a little bit more complicated, but we'll talk about that in another video. When I use simple trinomial factoring, I sort of split these problems up into two categories. The first category is when the third term is positive. The second category is when the third term is negative. To keep this from being a 20-minute long video, we're just going to focus on the first category right now and talk about when the third term is positive. To understand how simple trinomial factoring works, it's important to remember that factoring is the opposite of multiplying. So we're going to start with the multiplication problem and see what happens. In example 1, we have to multiply x plus 7 times x plus 3. So we're going to distribute here. X times x becomes x squared. X times 3 becomes plus 3x. 7 times x becomes plus 7x. And 7 times 3 becomes plus 21. But we're not done yet. We still have to combine those like terms of 3x and 7x to get x squared plus 10x plus 21. So this is what we get when we multiply those two binomials. What we're going to be doing today is going in the opposite order of what we just did. Factoring is the opposite of multiplication. So we're going to be starting with a trinomial like x squared plus 10x plus 21 and rewriting it as x plus 7 times x plus 3. So the question is, how are we going to do this? How are we going to go from a trinomial like this to two binomials that look like that? The x's make sense because when we do x times x, that gets us to x squared. The question is, where can we get a 7 and a 3 from if we started with a 10 and a 21 in the original trinomial? I want you to pause the video and try and think about that for a second. If we're looking at a 10 and 21, where can we get a 7 and 3? Pause the video right now, think about it, and come back when you have an answer. The answer is, the way we can get a 7 and 3 starting from a 10 and a 21 is that 7 and 3 multiply to give us 21 and they combine to give us 10. They're the only two numbers that fit that pattern. That's really the key to simple trinomial factoring. We're always looking for two numbers that multiply to give us the third term and combine to give us the second term. A quick public service announcement about the word combine. If I said combine two numbers, most people would think, okay, he just means add them together. But depending on the sign of the numbers we're combining can look a lot like subtraction. If the signs of the two numbers are the same, combining will still look a lot like addition. Like if I gave you a positive 7 and a positive 3. Combine them, add them together, we get positive 10. Or if I gave you negative 7 and a negative 3. The signs are still the same, so when we add them together, negative 7 plus negative 3 is negative 10. It looks a lot like addition. Put 7 and 3 together, we get a 10, even though one was positive and one was negative. But if the signs are different, then combining is going to look a lot like subtraction. Like if I gave you a positive 7 and a negative 3. If we add those two together, we get a positive 4. Or if I gave you a negative 7 and a positive 3, we put them together and we get a negative 4. Since the signs were different in those two examples, it ends up looking a lot like subtraction. 7 minus 3 gives us a 4. Again, even though one answer is positive and one answer is negative. So keep in mind that combining will look like addition if the signs are the same, and a lot like subtraction if the signs of the two numbers are different. Now we're finally going to look at some factoring problems, and as we go through them, I'm going to be talking a lot about how to choose the correct signs. Because even if you have the correct numbers, if your signs are wrong, your entire answer is wrong. In example 2, it says factor n squared plus 7n plus 10. We see that there's a leading coefficient of an invisible one, so that means we can use simple trinomial factoring to rewrite this trinomial as two binomials. The binomials will both start with n, so that n times n will get us back to the n squared, that is the first term. And now it's time to figure out what our signs need to be. The first clue I look at is the sign of the third term, what we're trying to multiply to get to. We can see we're trying to multiply to get to a positive 10. If we're multiplying two numbers to get to a positive, then the two numbers must have the same sign. They're either going to be both positive or both negative. And that makes sense because a positive times a positive is a positive, and a negative times a negative is also a positive. The way we decide whether they're both positive or both negative is by looking at the sign of the second term, what we're trying to combine to get to. Since we need to combine to get to a positive number, a positive 7, the signs in our answer will both be positive. This is the most important thing we need to learn from this video. If the third term is positive, then both of the signs in our answer will be the same as the sign of the second term. So that means if the third term is positive and the second term is also positive, both of our binomials get a positive. But if the third term is positive and the second term is negative, then both of our binomials get a negative. Now it's just sort of like solving a number puzzle. We're looking for two numbers that multiply to give us 10 and combine to give us 7. And since we're combining two numbers that are both positive, they have the same sign, combining is going to look a lot like addition. And the two numbers that fit that pattern are 5 and 2. So we just factored this trinomial. We rewrote n squared plus 7n plus 10 as the product of n plus 5 times n plus 2. We're done factoring. A common question I get when I teach this is, does it matter what order we put the binomials in? And not really. If we wanted to put n plus 2 times n plus 5 as our final answer, that would have been completely correct as well. Either of these can be our final answer. If you wanted to check yourself and make sure you were correct, all you would have to do is take your final answer, whichever one you chose, and just distribute it and make sure you get back to your original trinomial. Example 3 says factor y squared minus 25y plus 24. This checks all the boxes for us to use simple trinomial factoring. We see an invisible lead coefficient of 1, so we can use simple trinomial factoring to rewrite this trinomial as the product of two binomials. Both of the binomials need to start with y in this example because y times y will get us back to that y squared. And now we need to choose our signs. Remember, if the third term is positive, both of the signs in our answers will have the same sign as the second term in the trinomial. So both signs here will be negative. To pick the numbers, we just need to pick two numbers that multiply to give us 24 and combine to give us 25. And remember, since we're combining two numbers that are going to have the same sign, they're both negative, combining is going to look a lot like adding. The two numbers that fit that pattern are 1 and 24. Checking our answer is as simple as either distributing or just checking the combination and the multiplication. If I multiply negative 1 and negative 24, I get positive 24. If I add negative 1 plus negative 24, I get to a negative 25. So we can be pretty confident we did this correctly. We are done. This is its complete factored form. I want you to try these next three problems completely on your own. The only way to get good at problems like this is just by practicing. It's one thing to watch someone do it and sort of follow along with the video. It's a completely other thing to do it on your own. So pause the video right here, find your answers, and then come back and see if you got them correct. Here are the three answers. And remember, the order doesn't really matter. If you'd written this as b plus 1 times b plus 9, that would have been the exact same thing. So don't think you're incorrect if you just wrote them in the opposite order that I did. Did you get all three correct? Hopefully you did, but if not, don't get discouraged. Making mistakes is just a part of learning. Keep at it, and I know you can get there. Hopefully this made sense. If you have questions, by all means, put them in the comments section below. And until next time, enjoy the rest of your day.